Hello, this is Mike at Gamefromscratch, and welcome back to our ongoing Unreal game development tutorial series. Today we're actually going to be starting to look at making a bit more of a game. So far we've looked at little pieces, things like how to use the editor itself, how to create entities, how to create sprites and sprite animations using flipbooks. Today we're going to tie all that together and actually start creating a game itself. We're going to be looking at creating a player class. And that's going to tie together. It's going to have input control. It's going to have its own sprite for animation, etc. So we're going to start taking all the things we've learned together and learn to use them in a game-like form. In order to do that, I'm going to go ahead and create a new project here. Now, once again, I assume you've gone through all the prior tutorials, so anything I covered in the last tutorial section, I'm not going to go into it in detail again. So I'm going to assume you know how to use a flipbook. I'm going to assume you know how to create a new project, etc., etc. So I'm only going to cover the new things. This is the project I created. I'm going to create a fresh one for us, but the names are going to be very similar. Once again, if you go to the Gamefromscratch.com website, there's a text version of this particular tutorial already published. We're going to cover basically the exact same materials. In my case, though, I'm going to call it Pack Demo 2. I'm including no starter content, and I'm using a blank, we're making this a blueprint project again, and a blank project to start with. Just go ahead and hit Create, and it'll fire up and create a new project. I got to wait a few seconds for it to do its magic. And then, come on, I'm not on battery mode, am I? Yes, I am. Alright, that'll help. And here we go. Alright, so welcome to a brand new project. One thing I don't like is it doesn't load you into your default scene right away, and it automatically creates a bunch of things for you. When I say blank, I want blank. So I'm just going to go ahead and I'm going to get rid of everything it created for us. Like so. Then the next thing I'm immediately going to do is save our map. New map, good name for me. And we'll set that. So we now have a map. It's got nothing on it. Once again, where is my axis? Here, let me switch to front view. For a 2D game, we're always going to work in front view for the most part. And here we are about the center. So the very first thing I did do is I'm going to bring in a bunch of sprites that we're going to be using for this project. So just go ahead here and create a new folder called Sprites. And I will create another new folder called Textures. And let's go into our Textures folder and import the target files that we need. These are linked on Gamefromscratch.com. So go to the post. I'll put it in the comments below. If you want to download the exact images I'm using, you can. This is totally not Pac-Man for all legal reasons. This is just a circular pie-shaped sprite that we're using. And we want the background for our world. Very simple animation we're going to go with. Just a 3-frame animation and then a background to make it look like a game for the most part. So we're going to go ahead and import all of those. And then right away, actually for each one, I don't want bitmaps. Let's turn them off. There's probably a way to do this all at once using the attributes editor, but ignore the garbage. It's picking up my erase job, so if I put the alpha channel back on, it'll look exactly like what we want. So let's go ahead and turn that bitmap off. And finally our background. No bitmaps. No bitmaps for you. Okay. So there we go. We got all of our assets in. Now let's just go ahead and select them all. And sprite action, create sprites. So now we have 4 sprites, 3 for our animation, 1 for our background, and we shall just drag these over to the sprite folder and move them there. So there are our 4 sprites and our background. So now that we've got a background, let's make this feel a bit like a game. So just drag that in. Let's switch from wireframe over to unlit. And there you go. It's just a shot of a Pac-Man game. We may want to resize this a bit later. We're actually going to want to resize it a bit, so just hit R and scale it up like so. And then now we have a background. We want to go ahead and create our flipbook. We'll just do, yeah, you know what, I'll make a folder for it. I'm not normally this organized. Flipbook. This is where our sprites are all going to go together. So we'll just go ahead and go into this flipbook folder and create a new animation, sprite flipbook. And we'll call it pack flip. Open that guy up. And then we'll just come back over to our sprites, grab our 3 frames of animation, drag them over to our flipbook editor, and drop them in. So there you go. Here we got Pac-Man, a little bit overactive. Let's drop him down to, say, 2 frames per second instead. And there you go. There is our character animation. Incredibly zoomed, but that's it. And that's all we got to do. Just go ahead and save that flipbook, and we'll exit out. So now we're going to want to go ahead and create a character to use that particular flipbook. Where did my flipbook go? Okay, it's right there. So there it is. So now this is all new. This is where we start with the new content. In order to create, I'll go ahead and I'll show you the options first. We're going to be creating a new blueprint. So new and blueprint class. And I'll come up here and it's going to give us a bunch of parent level classes to choose from. Now I'm going to take a second to explain the object-oriented metaphor that Unreal Engine has gone with. It's useful to understand this because this is the key to the entire design here. And these most common classes they're showing us here are very important. Now, the Unreal Engine, like Unity and a lot of other popular engines right now, is component-based. That means that you add properties or abilities to a class by giving it components. Now, generally, you need a container for those components. That is the class that the components are going to be added to. That class is an actor. Now, an actor is a base class, very, very, very base class in Unreal Engine, and an actor is pretty much a component container, so a thing that can hold components that has a 3D position. So think of an actor that way. If it can be rotated, scaled, and translated in a 3D world, and it's got components, it's an actor. Okay, so the very base level class, or pretty much anything that's positionable, not even necessarily renderable, but physically positionable somewhere in the world, it's an actor. Now we've got a couple of classes that specifically inherit from actor. And the first one here is pawn. Now a pawn is an actor that receives input. Now input can come from 2 sources, us as the player or as AI. So a pawn is basically an actor with a controller, and the controller can either be us as a player controller or an AI controller. We're not going to touch on AI controllers yet. We'll touch on them later on. But essentially, this is the hierarchy. So you've got actor as the base class. A pawn is an actor that can be controlled by either AI or player. And the next thing you've got is a character. A character is a pawn derived class. So ultimately it's an actor, but it also has the character controller built into it off the hop. And this is sort of where we've used, and there's the player controller we were talking about. But the character itself is, again, it's just an actor, just a pawn. It's just very specific. Think about it, just normal and object-oriented inheritance. A character is a pawn is an actor. But a character is specifically for us to be controlling it. So it's going to get a couple extra classes to help and handle that stuff. And these characters are all going to be made up of a set of components, actor components specifically. Game mode is another class. We're going to touch on that one a little bit later on. Basically, that's the rules of your game. You're going to need to have one of them, and we're going to create one by the time we're done. There's a default provided, but it doesn't help us in what we do. Don't worry, just remember that game mode is another important class, and we're going to touch on it later in this tutorial. So quick relapse before I go on. Actor is the top level class of all things that contained in the world. If it's got a position, it's an actor. Doesn't necessarily mean it's going to move, but it's got 3-dimensional details available to it. As you can like this will come from an actor, for example, the transform details. And it's a component container. Now, a pawn is a more specific kind of actor, one that can be controlled either by AI or by the controller, and a character is a even more specific pawn that is designed as our main player character. Now, we're not actually going to use any of these. We're going to drop down all classes over here, and we're going to go one level deeper in the inheritance tree, and we are going to create a paper character. Now, this specifically is a character, but inherited in terms of being paper, our 2D library oriented. The biggest difference here is one has a mesh, the other one has a flipbook. So the visible, that's where the paper gets a bit different. Instead of having a mesh, it's not 3D, it's 2D, so it's going to have a flipbook as its visual representation. So just go ahead and create one of those. That's going to be our main character, and we'll select it, and we'll just go ahead and rename it my player, like so. So this is our brand new blueprint for our character. Oh, and I created it in flipbook. Let me just move that out. Let's put that in the root. All right, so we now have our player. Let's go ahead and create one. So as I said earlier, an actor is a component container. It's got a number of components, and then specifically our paper character is inherited from character, which in turn is inherited from pawn, which in turn is inherited from actor. So when I say actor, I'm actually talking about all of those things, not just actor specifically. But like I said, they're composed out of components, and this component is made up of a capsule component, an arrow component, dictating, so our capsule, our arrow, our sprite, or technically a sprite book, so poorly named in that regard, and then a movement controller. This one, a movement component, sorry. So these are the components that go together to make up our character. So first thing, let's make this thing visible. We just grab our sprite here, and we're going to set the properties on. We're just going to go ahead and set that flipbook to our sprite. So on the left hand, select the component we want to work with, our sprite, and then on the right, set its flipbook accordingly. Now we're going to want to size this capsule. The idea behind this capsule here is for 3D collisions. 2D collisions are basically 3D collisions where we're ignoring an axis, at least for now. So when you're dealing with a rapid, did something hit something else? You know, we can get into per pixel collisions later on, but for top level tests, it's nice to have this container that's built over it. So that's part of our player, is they pre-made this capsule container for us. Now you'll notice the sizes suck. They don't match our sprite at all. First thing we're going to do is go ahead and just change that. And that's down under the shape here. We got two values to work with. A radius, like so. So let's shrink it down more in line. Let me just switch over to front perspective, like so. Alright, so that fits pretty accurate. You can see its size changing as the sprite's moving, but so we ultimately want to encapsulate the entire thing. And then our capsule height, about there. Alright, so that'll work. So we now have a nicer sized capsule around our sprite, like so. That's our direction facing, and yeah, that's about it. We now have a game sprite. I am totally forgetting to do something. I don't remember what, which is why I call it forgetting. We'll find out in a second. Okay, so we now have a main character. Our main character, in turn, has a bounding volume, a directional arrow which way it's pointing, and our character sprite. And then, of course, the movement, the character movement component, which we have not used in any way whatsoever yet, but warning, we are going to. We'll just go ahead and compile and save that sucker. So now, here's our game, here's our world. We need to add that guy to it. And remember earlier on, I told you about that super important game mode attribute. Well, let's create one. So by default, there won't be one. You'll see, if we come down here to project settings, game mode, there isn't one. Or world override, not overridden. So this means we haven't created a game mode yet, and we need to now. So just go into one of these two, go over to game mode, and then create, and then game mode. By default, it's going to want to call itself new game mode, and I'm content with that. We'll create this in the root folder. Oh, I have a blueprints folder. Why am I not using it? All right, that was stupid. Well, anyways, here is now our game mode controller. For the most part, this is meaningless. The visual aspects mean jack. You can do some things on construction or on games firing off, but generally also you don't work at this level. Where you do work, though, is over here. This is the super critical stuff. Think about your game mode basically as, again, the rules that set the world up, but most specifically, you're tying certain classes to certain key classes that are built in. And our first one is this default pawn class. So now we want to say our my player. So we want our default pawn class is going to be the class we just created. So when the game starts, it's automatically going to create one of these pawns for the player. All right, and that should actually hook up this automatically. So I don't think we need to do any more, but that thing was super critical. So now let's save that, do a compile, make sure everything's fine. Yes, it is. All right, head on back to our map. And now we need to position that sucker somewhere in the world. And there's a twofold part to this. First off, when I created this guy, I should have pushed it to the background. So we're going to make it offset somewhat. Our default, when we're creating our component, it's by default going to be at 0 and 0, 0. So now we need to position it in the world, though. So we want our sprite to appear on top of the background. So I move the background back along the y-axis. Remember, again, the y-axis is virtually into the screen. So when you're dealing with depth in Unreal Engine with 2D, depth is y. So once again, x is this, z is this, and if you could picture me putting my hand in and out of the monitor, that is y. So we want to push y back a little bit so that our character controller will be drawn in front of it. But now we need to make it so that our character starts somewhere. This script we just created, this new mode script, this default pawn class will automatically create an instance of my player. But where will it create it? I think by default it will create it at 0, 0. I'm not 100% there. But what we want to actually do is use a player start control. And it's this guy. So over in the modes, just type in player to go, and then we want player start. You just take that guy out and drag it into the world. Like so. And now this is where our player is going to spawn. So let's go ahead and see where we're at right now. Actually, we're not anywhere because I did something stupid. So now let's go back to our player component, and we're missing something here. A camera. Now, you don't necessarily need a camera in this case. You could actually create a camera at the global level. Well, what we want instead, though, is a camera that's going to follow our player around. And that is it's a component. It's just another component. And you come in here, and you just go add camera. And now we have a camera. So first thing we're going to want to do is we're going to want to reorientate this camera so that it's not right up Pac-Man's butt. So just click it. Let's see, it's a little problematic when you first create it. And then we're going to rotate it 90 degrees, like, come on, one more. There. And then we are going to move it. Like so. All right, so we now have a camera component attached to our character class, and we can compile and save that guy, and now it will be in here, and that camera is now going to control where we are drawing. So let's go ahead and run this and see if we've made any mistakes. And I know we've made at least one right now. Something's not going to happen as we want it to. We'll fix that in a second. But let me just go ahead and run this game and see what happens. That's exactly what I expected to happen. So our game is working, our camera is right, but what happened is Pac-Man just fell. And the reason for that is we are creating a 2D game, but this is still ultimately a 3D game, and it has physics attached to it. So let's go on over to new map. There's a couple ways we could fix this. We could actually make our character not respond to physics or physics along those axes, but we may actually want to use it later. So instead what we want to do is turn off gravity. So in the world outliner over here, just bring up your map, like so, find the physics section, and override gravity. So you'll see gravity on the z-axis, that's this one. We are overriding how much is applied, and we want it to be none. So you pull this down, a couple more options, but for the most part, all you want to do, override world gravity as true, and set gravity to nothing. So let's save that, and let's run. Ta-da! Our Pac-Man is working perfectly. You'll notice he's a little bit sized differently than the background level, but seeing as the background isn't really a level, I can live with that. Here, we'll go ahead, we'll do a quick scale. There, Pac-Man should now look better. Alright, needs to be positioned slightly smaller, but let's, come on, W. Yeah, that's fine. We'll go ahead and play. Good enough for me. Alright. So we now have a very game-like thing going on here. We got a main character. The main character is automatically created by that new game mode script. That's what when we defined it as the default player pawn, that's what it went ahead. It goes ahead and creates an instance of our character, and you can see the flipbook animations automatically happening. Now what we want to do is add a little bit of movement to this guy. And we're going to do this the super simple way first. Actually, we're going to do a super simple way in general. But that is... load up your player. I can do it from here. Alright, so we're back into the editor for our player. But now we want to go back to the event graph here. I don't want any of this default junk, so let's just get rid of all that. And what we're going to do is make a very simpler keyboard event handler. So for each of the keys we got pressed, so the left arrow, right arrow, etc., we're going to move it in the corresponding direction. And we'll just go ahead and we'll create one for the right first. So go type in right, and you want key events. So key event right. And this is an event that will fire when the right key is either pressed or released. And we're going to go ahead with release. That way you got to do a press and release cycle to have it fire off. And now what we want to do is move the component. So we're going to need this guy here. We'll bring it in. This is our character movement component. And let's go, it's update component. And it's move updated component. And that's this guy. So all we want to do, right key pressed, fire off this move. Our target is our character movement component, which is responsible for all the movement on this character itself. So we're going to wire it up as the target. Come on, you. Oh, target is character movement. Why are you already? Okay, so it's already wired up. We don't need that guy. The target is fine. So you can see here the target, it's already targeting, so we don't need to bring in the target as it stands. And then finally we just want to update the direction. So X we shall go with 20. So if the user, oops, I did pressed. I meant released. Alright, so let's delete that pin. And do released instead. Functionally it doesn't make a rat's ass of difference, but we might as well be consistent with what I'm actually talking about. So now when I go ahead and play this, if I hit the right arrow, we move. Now this is, I'm using this particular function because it moves it just once, and I want to kind of emulate that kind of single press and go. We could also do movement where it said, you know, move constantly in this direction at this speed. But in this case, we're not doing that. Now let's go ahead and add the same thing for all 4 cardinal directions. And so that was right. I'm just going to take this section here and do a Control C, and then we'll Control V it, and then V it, and then V it. See, and the copied version created it as I was. I don't get the logic sometimes of Blueprint, why it didn't do what I wanted it to, and then now it's doing exactly what I wanted it to. But here you can see it's actually setting the target. It's the first time it set it for us. It's a matter of how I created it, I'm assuming. So, alright, so what we want to do now is change, instead of just being the right key unpressed, we're going to want to switch it to left, up, and down. So we'll make this one right here left. And so you come up to properties here, you can see the properties for the key events. And the key event, you can have it also need the modifier keys, such as Control, Alt, Shift, and then the max command button. So if you check this, then that key is also required for this event to fire. You can also set it to consume or not consume input. This means if you unclick this, this will get the event that the key was fired, but then it'll continue firing it off, so other people can respond to it as well. So we want to change this guy to, actually, we'll change this guy to left because it's to the left of. Alright, and we want to change this guy to up, and this guy to down, like so. And then the killer is, so the left now, instead of this, we want it to go the other direction. Up, instead of X, we want it to go on Z. And then down, we want it to go on Z. And we want it to go down, like so. So in theory, if this is right, we should now have simple keyboard input using the arrow keys. There we go. Perfect. Now, I should point out, this is a simple way of showing you. This is the very easiest way you would wire up to handle a single keyboard event, but it's also sloppy. It's kind of the equivalent of copy and paste coding, which I guess is exactly what it was. What you would probably do in the real world is have this pass through and do it with a variable in the middle. I'll go ahead and actually show you that process. So instead of this approach, we would go... See, right here, delta, the change value, actually can be taken in as a movement control. Sorry, as a vector. My brain's not working there. Sorry. So what we could actually do is have created a variable instead, and we'll call this one move x. So this is movement along the x-axis. We just create a variable for it. We set the variable type to vector. Once again, you got this handy color coding. So this color here matches the input pin colors. And then we could take this down a bit, and we could break this pin. Now, you're not going to get a whole lot out of what I'm about to do, but you... Alright. So, if that is pressed, sorry, if it's released, we want to set, what did I call it? Move X. So go ahead, drag one of those in. Like so. And boom. And we can set move to 20. Like so. Or we can, let's copy and paste that guy. Oops, that's a negative. Negative, big buddy. Positive over here. So we do, man, why do I keep doing release? Alright, undo. Let's get the right one hooked up. So, like that, and then each of these sets then flow into a single update move. So instead of needing this guy anymore, we'll just get rid of it completely. And you could have your flow instead go like this. Like so. So now, exact same process, exact same end result. Oops. In theory, the exact same end result. If left is released, we want to move left. Oh, I didn't wire these in. Sorry. Now you'll have the same result. So the input value of this pin is now being fed by this variable we created. This move X variable. So here's slightly more complicated programming, but I could in turn turn this into a function and collapse it all down into a single box. So it looks more complicated than what we have. It introduced a variable. We could have made a local. We didn't need to make a variable, named variable at all for this, but it's cleaner in my opinion. But this same functionality as this just allows us to do a little bit more logic, a little bit cleaner, a little bit more intuitive. And we're going to actually have to add something here, is if our character flips. So now it should be working right, goes either direction. But you'll notice Pac-Man does not orientate in the direction we want it to be. Right? And that's not good. So let's look at fixing that. And part of the solution is one more variable. I'm going to come down here to variables and I'm going to create a new one. A Boolean this time. And we are going to call it is facing right. Like so. And yeah, I think that's good. Alright. So now we have an is facing right variable available to us. And now we're going to allocate it on when our program starts. It's not being on. There we go. So this is an event on event begin play. This is one of the ones we actually deleted when we first started. And this is going to be called pretty much when this script is first fired. So this is kind of like the constructor, I suppose you can think of it that way. And what we want to do is just take this variable here and we want to allocate it. So, oops, I missed. Let's undo that. All right, so bring this variable. We want to do a set on it, like so. And so when we start our game, simply want to set this value to true. So now when our game starts up, it is going to say, we are facing right, which when we start the game, that is actually true. So now what we want to do is do some if logic. So if we hit the left key, but we're facing right, it means we just flipped. That means we need an if. So right click, go if, drop in a branch, like so. We need a condition, like so. So we're going to get our is facing right logic here. And we are going to connect that as our condition. We are going to break this pin. Die pin. Alright, so released. And instead we will jump into our branch, like so. So this will test if we are facing right or not. And if we are not, that means we have to flip. If we Alright, so let me give him the logic for a second here. Yes, so if it's a left key press and is facing right is true, that means we currently flipped and need to do something else. If it's false, we just want to pass through like normal. Okay? However, it's the true that we now have to deal with. Let's drag these guys down a bit. So, in the event that it's true, we want to go ahead and actually flip the sprite component. And that is going to use a local transform. So let me just drag in here. Actually, let's pick our sprite right here, and we'll grab it that way. Add a function call on sprite, and it's under, nope, components. All right, give me 1 second. I need to look this up. So what we want to do is locally flip our sprite if, so basically we want to invert our sprite in the opposite direction if we're going in the opposite direction. So now we're just going to go ahead and add local rotation. So add local rotation like so, and we will drop this guy in like that. It goes out to our set like so. We need a target for that, and we want our sprite, so just drag our sprite in like this and connect it as the target like so, and we want to rotate 180 degrees yaw, I believe. Maybe wrong on that one. I always mess up my yaw pitch and roll, but let's go ahead and find out. So now we hit, I go in the opposite direction, and I turn. And then our back now, we need the logic reversed. So let us fix it there as well. You know what? Probably faster to just delete right. And grab all of this junk like so. And copy and paste it like so. Hey, you get out of here. Like this. Change you back to right. Like so. Connect you to your set instead. Like so. Alright, so that's our branch. Our logic here is inverted, however. So instead of true, break pin, we want false instead. So I hit right, and absolutely nothing happens. Alright, I broke something. Right is released. Condition of is facing right is, oh, sorry. In the other case, we need it to still go ahead and do something. So we're facing right, we go this way. Now we go left, oops, we have a logic error. Yeah, that makes sense actually. So on left, we're flipping the first time, but then we're flipping again. So that local transform should actually only run once on change. See, that's kind of a bad thing. So we need to add a small bit more logic here. Let me think. I'll pause while I think. That's always painful. Zoom this guy back in. So it's the logic here we need to revisit for a second. So on one flip, we want to locally do this, but on a second flip, we do not. So if we're already going left, we don't want to do this. So we could do this with another flag, but that might be ugly. Alright. No, I'm just an idiot. I forgot to set this value. Here. We're never actually flipping it back. So if we're facing right, so we have this condition, and then we check, and we do this flip otherwise. Well, the problem is, we are now no longer facing right, so we just need to change this slightly. You know what, we can do it after all of the logic, actually. So after this set, in this case, we're always now, once we get to this point right here, this is always going to now be false. So let's just do a set. Set is facing like so, and we set that to false now. Drag this over. This pin instead goes to here. Then that pin instead goes to there. Now, I think I dragged it into the wrong output. Ah, yes, I did. We still need to configure our move point. And now, left goes left, right. All right, now I screwed up right. Oh, I suppose I have to set the variable in its case too. So we need to have this same logic. So we'll do that as a copy. And then up here, and somewhere in between, anywhere between this set and, well, actually it needs to be called regardless. So what is going to be called regardless here? The local transform, the branch both go to the set. I'm missing my set on this side. Oh, I've screwed this all up. I'm sorry. That's why this makes no sense. All right, let's break this pin. My bad. It's all right. I co-opted this poor guy's set. So this guy's going to go right, right? So let's switch that to 20. And regardless of how this turns out, we want that guy to set. Like so. However, then we want to go ahead and set this value after, like so. Either way, like so. And then both of these feed into here, and our results feed in to there. My bad, that was just stupid. So now right goes left doesn't. Okay, I just broke everything. Just that. I'm going to pause. I am screwing up my logic here. Well, first of all, is facing right. In the case of facing right, always needs to be true, always needs to be false. That might have actually been it. I'll assume that was my mistake. Now we'll go ahead and play that. And here we go. So right arrow, left arrow. And theoretically up and down. Right. So there you go. There's basic direct keyboard input controls. And then a little bit of logic on doing a local flip. And we'll walk through this very quickly once more because my bungling about made this much more confusing than it had to be. So let me just trace through the logic that we're going with on the right key press. So this is a right event handle. This is fired when the right key is pressed. And as you saw over here, you got these modifiers, but none of them are set. So we don't need control to be held down, alt to be shift, or command to be held down. So just the right key is pressed, then this event will fire. On the event that we actually care about the release of the key, not the press. And then what that's going to do is feed into a branch. It's going to test off of this variable. This variable is being set when our game launches to a value of true. So we're going to check to see, are we currently facing right? And in the case that we are facing right, we're just going to go ahead and set our updated value. If we are not facing right already, then we're going to flip 180 degrees and then go ahead and set our value either way. So you see, all roads lead to this anyways. And then finally, we're going to set every single time the is facing right. So yes, at this point in time, no matter what you do, you are facing right. This updated why did you even work? This updated calculation then is fed in as the delta amount to be used on our move updated component. The component itself that is being updated is our character movement controller, which we wire in here as the target. And then basically the exact same logic on the left arrow being pressed, except for our logic obviously is flipped for true and false because we want, if we are facing right, we are going left, we want to go left, etc. So really the only difference is, in this case we process on a false, in this case we process on a true. And at the end, instead of setting it to true that we're facing right, we set it to false, so in other words we're facing left. And then otherwise update it as normal, and here is your end result. Basically simple keyboard move controls. Very cool. However, a lot of times, and we're not going to cover this in too much detail, I'm coming up on 40 minutes already, but you're going to want to deal with controls not like this. There's a lot of downside to this particular approach. First off, it's sloppy. We could turn this all into a function that generates this automatically, drop it off, and basically call it handle keyboard function, and get rid of this messiness that we've got. But the logic is a lot easier to see if it's all together. So these are your left and right handlers with some logic built in. Where here is your very simple, just on a key do something. So on key up being released, update the character movement component, by 20 in the z-axis. And that's as simple as it can get. Now, however, what if you want to do the same thing with a joystick? So if they press right on the D-pad or the up on the D-pad, you want it to fire and do the same logic as here. Well, in theory, I could go ahead and go input, and then, let's see. I could do mouse up event, key up event. There are also, actually, it's either joystick or controller, joy. Gamepad. Yeah. I could do a gamepad D-pad up event like so, and I could actually even reuse. Like I get there. So we wired up now both of those events. If you press the D-pad up or you press the up key, it'll fire into this control. But this is going to get sloppy fast. And a lot of times you're going to want to deal with things a little bit more generic than what we just did, or you're going to want to have, you know, analog controls or virtual controller controls, or maybe you even want to give the player the ability to customize their own controls. Well, how do we deal with that? Let's first off deal with it by saving everything. This could get kind of confusing. We come up here to edit, and there's project settings. These are settings for the entire project and scope. Things as you can see, the game name, an ID, version codes. You can put your own publisher information up here, your legal notice, blah, blah, blah. And then there's across the bottom here all kinds of default settings you can do, and then the settings for each individual platform as well. What we care about today is our engine settings, and specifically input. So click here, and what we want to do is set up a binding. Now, a binding is basically a mapping or a generic event that can fire that we then add to a bunch of different controls. And that's exactly what we're going to do. We're going to do an axis mapping for left, and we're going to handle the left event being fired in the event of the left arrow, the A key, or pushing left on the D-pad, or left on the analog controller. So we want all of those things to fire a simple left event. And we just come here, axis mapping, and hit the plus key. So now we've mapped a new axis, and we'll call this one left axis, like so. And by default, we have one entry for it. And we'll just go ahead. We got a keyboard, and that'll work. So we want key left. Scale we'll get back to in a minute. I'll explain that later. So now we're going to do a plus and add one more. In this case, we're going to have keyboard, and then we'll have A, like so. So you got your WASD keys, or you've got your arrow keys controlling it. And next up, we're going to go ahead and map in the gamepad, D-pad left being pressed. And then finally, the gamepad. I don't have any hooked up right now, so I can't even demonstrate this, but left thumbstick, gamepad, left thumbstick left. All right, so they all kind of come out here. They all handled as a single event. So instead of dealing with left or A or gamepad left or gamepad left thumbstick left controls individually, we can now use this as one entity. So close this out, and let's go back to our player script somewhere here, find a blank space. So instead, if we wanted to respond to left, we just come in here and we can just go left axis, and there's our axis event automatically for us, and we'll just drop him in. So this will fire when anything happens along the left axis, and you'll notice here this axis value. This is a float of the amount of movement on the left axis. And for, I don't know if that, did I close that window? Yes, I did. That scale value, that's where that comes in. This is a floating point value that will come out and represent how far the controller is pressed along that axis. So you're in your event of D-pad, keyboard, etc. Those are all on-off settings. So your axis value is basically going to come out as 1. That is on. Whereas your thumbstick is an analog control, so it can have different values. If you're halfway there, it could have a value of 0.5. So what you could have done in that settings, let me just go back, bring it back up, is in that input settings here. If you wanted, let's go get our axis mapping back, left axis. If you wanted hitting left on the keyboard to be the equivalent of pushing your D-pad halfway to the left, you could scale it this way. So then the value that comes out here, let's close that down, in this axis value, instead of being 1, it'll come out as 0.5, or like half of the original value. So this means that hitting left on the left arrow would be the equivalent of doing half of a left thumbstick. Or you could map the thumbstick backwards or whatever, but that is what that particular value does, and this is your input result as a result. So if you want to use Now logic for the speed to move by or whatever, you can use this axis value to help calculate that. So as you can see, you can actually set up these nice handy input mappings over here in your project settings that then in turn can be used by the name you create, as opposed to having to deal with each thing specifically. You can also do the same thing on action mapping. Very similar, a little bit more generic. So here, say keyboard enter. We'll call this the enter map. You're going to end up with very similar results. We can add one to our enter map, like so. The only difference between the axis and the action map is the axis is set in of the axis value, that variable floating value, depending on the amount done, whereas an action map is on or off, or pressed or released, or whatever. That's the only difference between those two settings. So if you had like a jump button or an escape game button and you wanted to have multiple controls or multiple mappings, you would use action. If you've got axes, so something that has a variable amount left or a variable amount right, a variable amount top, variable amount bottom, you use the axis mapping instead. Coincidentally, you can actually use action mappings for left, right, up, and down if you really wanted to. You don't need to support analog controls. So you can ignore this completely. If your game doesn't need variable sensitivity controls, you don't use an axis mapping. You can just use action maps for all of that. So there. I want to keep my input as one press is one move, so we're sticking with what we've got now. So that's the extent of what I'm going to cover today. There's actually quite a bit covered in there, so I'm not going to add too much more. It's very confusing. So I will do a very quick recap of what we just did. So we came in, we created our new map. Our map is simply a background sprite that's moved a little bit. Remember, we moved it back, details, we moved it back 50 on the y-axis so that it's behind our character sprite. Then we went in and we created those three sprites, and we used them together to create our flipbook. Our flipbook is then in part of our character. Remember, our character is created as a blueprint. When we created it, add new blueprint, and then we picked a paper character control. So these different relationships are very important, but remember, all of these are essentially just component carriers. So actor components are what make these things do stuff. And we could have gone ahead and we could have created a pawn and gave it all of these components by hand itself. We didn't need to make a paper character, but a paper character is just kind of pre-configured to have all of the different components that we would require. So once we had made our guy, so here he is, and it is composed of a couple of pre-existing components. Now we went ahead and we added a camera on top. This will keep the camera pointing at where our player is. Now if I go ahead and press play, we can see it right there. Now remember when we were setting up the position of our camera over here in the viewport, if I move this guy slightly back, when we play, our camera will be slightly back, or slightly forward. Our camera is slightly forward. So that is the effect of this relationship here. Remember, you don't need a character. You don't need a camera for your character, but if you want the camera to follow your character around, you would use that. Also, in a more advanced game, in this case I don't really need one, but I'll show you anyways, you could actually set up a swing arm, which if you think in terms of movies, it's the thing that a camera sits on, and it allows you to keep your camera at a fixed distance away. You can set properties up like don't run into walls and such, and that's just another component. And this will nicely show the relationship of components, though. So inside of our component, I'm just going to go ahead here and say add new component. It's down here with camera. It's called the swing arm, like so. And then we're just going to add our camera to the swing arm. So now the camera is a child of the swing arm. So as the swing arm moves, the camera will go with it. And the swing arm has other sets here, like for doing collisions with other stuff to stay things out of the way. And the biggest one is normally, arm length. And this is just the distance between the camera and the target. So we could do it this way, it'll be closer, go ahead and press play. The swing arm is now controlling everything. Now the swing arm is at a weird angle, so we need to move everything back. But this shows you the component relationship, how things are related. So that I now have this component that is controlling this component, which is still part of our player. A bit confusing at first, but it does make sense. Ultimately, anything in this world is an actor. Those actors can be controlled or moved. Then generally it's a pawn. That means there's either AI or a controller running it. Or it can be a character, which means that there's actually us. We are involving it. We're running it. And the character is normally just there to add this character movement component. And you'll look over here and you'll see all kinds of crap set. that if we were doing a 3D game, it gives us a lot more that we don't need. Like, so you can see over here and set how that character it deals with things in the world, in the physics world, etc. How high, how fast they jump along the z-axis, etc., etc. Now, mostly we're dealing with 2D, so a lot of this is completely and utterly useless to us. But you can see how a character is very, very, very handy for a more involved 3D game. But ours is, we're not using 95% of this, and we could probably get by without one, to be honest. But that is the relationship. That is key. We did some events for handling input events, and we just finished covering that, so I'm not going to go through that again. But the other important thing to remember is, in order to hook our pawn up, we had to create this new game mode, and that was set by here. You go into the blueprints, and you set the game mode. So our game mode is set up as World Override. We are using a new game mode as our game mode. Let's go into new game mode for a second. And all you're really in here for is this guy. And specifically, we're setting up our default pawn class as the one we just created. This means when our game starts and it creates our player, it creates our player as being this guy. Finally, we needed to tell our player where to be created at. And that's what this guy does. This is just the player start controller, and the player will automatically create itself at the player start location. I think that's about it, to be honest. Oh yeah, the only other thing we did was remember to go into world settings and turn off gravity. Otherwise, your player just falls straight through the map. So that's it. That is the beginning of adding logic to our game. You can kind of see how it goes together now. We could have done it with an AI controller, and instead of responding to input, we would have controlled our own logic. And we will actually cover that shortly. So. Stay tuned, but it's going to be much of the same process. And you can see now we're starting to take a bit more of the form of a game. We're getting there. So please stay tuned for the next part. I hope you enjoyed that. Thank you very much. Bye.